Hey everybody, this is the lab for nuclear chemistry, modeling radioactive decay. We're going to do that using candium, and you get the choice, but we'll get into that in a second. First, background. You need to tell me something about what on earth half-life is. Something to the effect that, half-life is the amount of time needed for half of a substance to be left, and that it's an intrinsic value, and I want it in complete sentences, and you're going to do that background information. Then you're going to watch this video and fill out the procedure, and then you will be able to model what's going on for the half-life of candium, which is your choice. You'll get to choose between Skittles or you'll be able to choose between Skittles or M&Ms. So when you're done and you have that piece done of the lab, you're going to come see me and you're going to get two things. You're going to get a cup of candy, and you'll get much more than this, and some paper towel. The paper towel is so that we can perform the lab here, and then the candy's not on the table and we can still eat it. Feel me? You can't eat it till it's done. So here's the first steps. First step is you need to count how many you have, and you need to make sure that they're all viable candidates, which means they have a letter on them. So I'm going to make sure that they're all letter up and that they have a letter. And if they don't have a letter, take them out and eat them immediately and make sure they are not part of this lab. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 candies. So I'm going to say at 0 shakes, I have 15 undecayed and 0 decayed. Make sense? Okay, good. Then I'm going to put them in my cup. All the ones that are able to go in the cup. Remember, I already ate the ones that don't work. And I'm going to shake them up and pour them out. And now everybody that's face up is decayed. So he decayed, and this guy, and this guy, and this guy, and that yellow one has got an M on it. I see it. So that one decayed. Oh, and this orange one decayed. Okay, so I separate the two piles. So now I have 1, 2, 3, 4, 5, 6, 7 that decayed. 7. And I got to have 8 that didn't decay. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now this is where things get crazy, and if you screw this up, I know you didn't watch this whole video. Okay? I'm going to leave my 7 that did not, or that decayed. They are out of the game now. I only pick up the ones that are undecayed, and now I go through my next half-life. Bam, here we go. And now how many decayed? I got 1, 2, 3, 4 decayed, 4 didn't. Okay, this is where students make the greatest error, and I'm going to show you what not to do. I have now 4 undecayed, but notice it says total number of decayed. My total now is all of these. The first 7 plus 4 more is 11 now that are undecayed. So notice, 15 plus 0 equals 15. 8 plus 7 equals 15. 4 plus 11 equals 15. You need to be able to total them up and have the same number every time. What I don't want you to do is to say, in my second roll, 4 decayed and 4 didn't decay. That is going to screw everything up. You will not get accurate data if you do it that way. What you're going to do is complete this whole trial until there's none left to shake. When there's none left to shake, you're done with that trial. Then everybody goes back in. Everybody's back in play. You can't eat any. You don't want any dropping on the floor because you want the same number every time. I'm going to go through the whole procedure a second time. Okay? And then did you get exactly the same results? Probably not, but probably pretty close. Guess what? You're going to do it a third time. Then here you're going to average, and this is the average here. So I say the average of this box plus this box plus this box. Well, it's 15. I know this one's going to be 15, and this one's going to be 15. So 15 times 3 is 45, divided by 3 is 15. Bam, here it goes. It's 15 plus 15 plus 15 equals divided by 3, right? Average. And here's where we need to be careful of this. I'm going to say that every half-life is 10 years time. So this is going to now be 10, and this is going to be 20, and this is going to be 30 as far as years go. And I'm going to get my averages here, and then I'm going to plot. And I need to set this up in such a way, right? And it says set your scale on the y-axis to be 3 atoms per increment. If you decide this number has to change, I'm okay with it. I'm just giving you a heads up of what it should or could be. So your time goes down here. Your number of decayed and undecayed atoms go here, and you're going to make 2 graphs, okay? Graph both your undecayed and your decayed. So I'm going to graph one, that's going to be decay, and it's going to go like that. I'm going to graph another one either in pen, do one in pen, one in pencil, do different colors, or on your actual plots, you can do one with a circle and the other one with a triangle or something like that. And I'm going to have another one go like this. You're going to get 2 plots similar to this shape anyways. And where they cross, you look down, that's at that time is the half-life. And that's how we read half-life graphs. So here's my numbers decayed, here's my numbers undecayed. Where they cross is my half-life, okay? And then I propose what my half-life is, and then it says, look on reference table N, and which half-life could my candium be in real life? Okay, and that's, so don't freak out about that. Here we go. Restate the purpose. Claim. Half-life of your candium isotope is. Make an actual claim about what that is. Data and evidence. Cite your specific test results. My data shows that when I blah, 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 blah. Interpretation. By graphing the average, I see that where the undecayed and decayed cross, and then we are done. When you are done with all 3 trials, you can go ahead and eat your candium. And you, of course, get the choice again. Skittles or M&M's, your call. I think that I did a pretty good job of making sure all the pieces that could catch you up won't catch you up. But remember, we got to count the total undecayed. If that number isn't consistently going up, then you've done something wrong. All right? With the last lab of the year. Good luck.